Perfect. I think we will get going with today's anchor lunch talk. And my name is Elisabeth Kvarnström, and I'm today replacing Maria Lennartsson, who is the person usually presenting the anchor lunch talks. And the title of today's lunch talk is, What do the users of source-separated wastewater systems think? And before we talk about before we delve into the program, I just want to mention what Anchor is a little bit. And Anchor is trying to advance the knowledge around source-separated wastewater systems, and is doing it very successfully too, by working together with a number of demo sites that are implementing source-separating wastewater systems in Belgium, the Netherlands, Germany, and Sweden. And also, by evaluating how well these demo sites are working, we are creating new knowledge, for example, on reuse of grey water and how to operate and maintain vacuum systems properly. We're also engaging closely with stakeholders, and these lunch talks is one way of how we do that, how we reach out. And we're also producing tools and transition knowledge within the project. Sorry. And what is source-separating wastewater systems then? Well, I think you all know by now, but it's when you collect little minimal flow of nutrient-rich wastewater, for example, the black water, separately from the big volume of grey water coming from kitchen, laundry, and showers. And by doing so, you can better both treat the problems in wastewater and recover resources. And the partners in Anchor are 8 water utilities, cooperation, the Coop, research organizations such as KWR and Bauhaus University, and also the City of Stockholm. And Vito is the project manager. Did I say water utilities? We have 3 of them: Hamburg Wasser, NSVA, and WaterNet. This is the 8th lunch talk, I believe, and you can actually access other lunch talks through the Anchor website under events. And we have been talking about so far about both softer issues such as drivers for source-separating wastewater systems and societal benefits of the same systems, and agents of change. How do you get this change to happen? And also more harder technical knowledge has been transmitted in these lunch talks on black water and grey water and heat recovery. So feel free to explore more about the ones that we've already had. The agenda today is we're going to start with a researcher from KWR in the Netherlands, Henk-Jan van Alpen. He's going to talk about user perceptions of source-separating wastewater system, like an introduction, and a little bit about different types of users. And then Henk-Jan's colleague, Femke de Boer, will talk about what operators of source-separating wastewater systems thinks, based on her master thesis that she has written. She will continue by interviewing an operator, Lars Hordin from NSVA, who is operating the system in Helsingborg. And the last presentation today will be from Hamza Shestadius, who is a colleague of Lars, also at NSVA. And Hamza will talk about what gardeners and farmers think of the fertilizers produced at RecoLab in Helsingborg. And you will also be able to post questions in the chat or in the questions and answer tool. Okay, that'll be all from me. Henk-Jan, please.
Thank you very much, Elisabeth. I'll try to share my screen. Yes, thank you. So I will talk about what we call end user perception of source separation. Do you see the presentation now? Yeah. So we have been studying user perception of source separations in 2 different projects already. That's the SENSE project that was preceding Anchor, and the Anchor project, which of course you have also read, saw the introduction by Elisabeth. And both projects took place in the same urban case studies. De Nieuwe Dokken in Ghent, Superlocal in Kerkrade, Ocean Hamnum in Helsingborg, Jenevelde in Hamburg, and Schoonschip in Amsterdam. So we studied user perception in each of these 5 cases. First, a little bit about the more technical side. So it's really different. We are looking at really different systems from the traditional systems. So here you see a schematic view of the traditional system. You have a centralized scale, and there is water being produced. It's being distributed to the household, and then it comes back as wastewater to the centralized level, and there it's being treated. And it's a fairly not so very complex circle. But if you look at these new initiatives, they are much more complicated because they involve separate streams on all different levels. They involve food, they involve heating. So it's much more integrated. And it also means there are a lot of people involved in these systems. And that's basically what we are looking at with our research. We call them users, but that's not really a good term actually, because some people are actually using the systems, other people are designing the systems or operating the systems. Other people use products that come out of the systems. So there's a lot of different people involved, and they all have their opinions about the systems, their experiences, their ideas, their beliefs. And this is what we are interested in this research. So in this talk, I will first discuss what we call the end users, but actually they're of course at the beginning of the system. I will focus primarily on how people experience the vacuum toilet, and then Femke will talk about and with operator, so the people who are actually making the system work. And finally, Hamse will talk about farmers and gardeners, people who are using products that come out of the system. So this is what we talk about when we talk about users. And then we have perceptions. And it's important to realize that everything that people think about something is based on their experience with the actual system, but it's also based on certain beliefs that they have, certain attitudes, and the way that they process information. So we study this user perception to get an idea what people think about these systems, not only based on a theoretical knowledge. Let's say you present people with a system and say, what would you think about it? But also based on their actual experience with the system. So I will primarily focus on the work we did in SENSE, where we did a combination of qualitative and quantitative research. So we had qualitative explorative interviews, and then we had quantitative surveys. So that means you work with scores and means and data, and in the explorative interviews you work with stories and anecdotes. And also in the follow-up interviews you have these stories and this richer context. So the new thing about this study, and also what we do in Anchor, is that it's focusing on the actual users, so we can draw on experience. And in this study we focus primarily on the vacuum toilet, of which you see a detailed overview of how it works. We started with the explorative interviews just to get an idea about what's on people's minds when they use this, and also get an idea of what kind of questions should we ask. And we see a lot of interesting things emerge there. So unforeseen practices, people who are not really happy with the fact that there's so little water in the toilet, and they still want to have this fresh smell of the toilet block, so they spray the toilet block with a little bit of extra water. or some installation, which is very unfortunate, a button that you have to press often, which is hidden very way in the closet. But generally, from the explorative interviews, we already got the sense that they're content. So then we started with the research, with the surveys. So we sent out a survey in 5 cases, and we found that people are generally satisfied with the vacuum toilet. On a 5-point scale, it's 3 or higher. And it's a little bit different over time, and a little bit different in the different cases, but in general, people are happy. They would even recommend it to friends, so or family or colleagues. And also, they prefer a vacuum toilet over a traditional toilet. So if somebody had to choose again, they would choose a vacuum toilet over a traditional toilet. And we also asked them a little bit about their emotions, about their feelings when they show a vacuum toilet to visitors. And I never show my toilet to visitors, but apparently these people do, and they are very enthusiastic when they do. And sometimes they're a little bit uncomfortable or embarrassed, but usually they're luckily more on the enthusiastic side of things. So this is what we find in terms of appreciation. And then, of course, we are interested in how we can explain this. So why are people actually content with these systems? So we look at 3 different approaches. First, we look at the levels on which they can agree or not agree with a system. We try to break it down into different aspects. And we also looked at demographic factors like age or income or education. So first, the levels of acceptance. When you ask somebody, do you think a vacuum toilet is a good thing? Then people can answer that question on different levels. They can focus on, let's say, the individual level, the specific product, the specific toilet. But they can also voice their opinion about the process around which this technology is being introduced. For instance, the information that's come with it, the complaints, if the complaints are handled well, if everything is if everything is clear for them, if maintenance is being done regularly. And finally, people can also look at it from a social political acceptance. So for instance, they consider a vacuum toilet to be of societal use because it saves water, because it saves energy. So that's also a perspective from which people can accept a vacuum toilet. And we see, particularly in superlocal and Nieuwe Dokken, where we have studied this, that the social, political and the process acceptance is a little bit higher than the product acceptance. So people are more happy with the broader societal impact and the process than with the actual toilet. That's the view that we get from these 2 cases. If we look a little bit more on the different aspects of a toilet, then we see that sustainability and aesthetics score very high compared to traditional toilets, and malfunction and sound nuisance score a little bit lower. So the factors that contribute most to the positive score are sustainability, of course, is also part of the societal acceptance, and aesthetics, and also the safety in use. And a year later, we see more or less the same, but it's slightly less positive. So we see the positive view is it's fading away a little bit after a year. So on the level of process, we see that communication with the service provider is very important. So for instance, we see very positive response on the fact that there are clear signs on the property, that the expectations are managed about what is happening. Of course, it's a new technology. Maybe works a little bit different than your expected, or it malfunctions a little bit more often. That doesn't need to be a problem when expectations are managed, and also when there's good communication and mitigation of potential negative impact. And if we look at the demographics, we see that it's not really about age, gender, and education. We don't see any relation between these factors and the satisfaction level. So it's not that younger people like this better, or that men like this better than women, or that theoretical educated people like this better than practical educated people. There's not really a relation, but we see a relation in, let's say, the type of customer that they are. So we see that we have this four type of customers that we use in our research: aware and committed, egalitarian and solidary, down to earth and confident, and quality and health concerned. And usually we see the one-third division between the first three, and then a smaller amount of quality and health concerned. But in this case, we saw that a lot of people are part of the group aware and committed. So this may also influence their positive view, because these people generally are positively inclined towards sustainable technologies. So to resume, the first year we saw satisfaction in communication with service provider, hygiene and noise pollution were the most important factors in terms of whether you like or dislike a toilet. And later, a year later, it's more malfunctions and the acceptance of frequency and maintenance and repair. But this is statistical, and also you can have variables hidden behind other variables. So we still think that communication is important, but it's integrated with this malfunction and the acceptance of the frequency of maintenance. So the conclusion is that people are generally satisfied with the vacuum toilet. Their overall feeling is positive, particularly in the beginning, and over time it seems that it becomes more neutral, which is of course logical, because in the beginning you have a new technology and you're, wow, this is new, and then over time it's of course just a toilet, and how many feelings can you have over a toilet? In general, we also see that people have a very high living satisfaction in general in the neighborhood. So the neighborhoods are generally very nice. Demographics, age, gender, etc. are not very important. Creating awareness about experimenting and sustainable technology helps. And over time, the performance of the system is what counts. And from the interviews, we found a very nice result, and that's that people appreciate the fact that these technologies help them to live more sustainable lives, and it also inspires them to be more sustainable in other areas of their living. So this is my presentation, and I'll now give the word to Femke.
Yeah, thank you very much, Henk-Jan, and please go ahead, Femke.
Let us quickly switch seats.
Yeah, I'll put the screen on. Yeah.
Oh, thanks. Even more.
You can just please remind everyone to put your questions in the chat or in the question and answer too, so we can have them for afterwards. Thank you.
Thank you so much. Well, welcome to this presentation. First of all, my name is Femke de Boer, and right now I'm working with KWR, where I also conducted my master's thesis, where I researched the stakeholder group of operators, which are those who are directly working with the water systems through installing and maintenance, etc. let's see, in my research on the operators, I specifically included 4 of the 5 anchor locations. I only skipped one of the locations in Amsterdam because there were less operators there, or well, the people who live there are responsible for operation. So it's a little bit of a different stakeholder group, which is why I'm specifically focusing on these 4 locations. So what I did here during my master research within these 4 locations was conducting research on the perspectives and the practical suggestions that operators have. I collaborated with the operators to obtain specific information about their perspectives. And this is specifically important because operators are currently an under-researched stakeholder group, both in general within sustainable development, as well as in the context of decentralized water use, so the systems that we're discussing today. And it's important to address this because understanding like a social context of new implementations is important, for example, for gaining support. Due to limited time within this presentation, I will not go into the theoretical basis and the methodology of my research, but just to share, I've mainly conducted qualitative. 1 second, sorry. Yeah, I have conducted qualitative interviews for the data collection on the beliefs that operators have. And first I will shortly discuss some of my findings, and after this I will further discuss them with Lars, one of the operators that was also involved within my study and the research I conducted. Let's see. Well, one of the important results of my research was that it pointed out that the viewpoints of this stakeholder group of operators are both important to know by themselves, like what kind of opinions does the stakeholder group have, but also in a broader context, why do these operators hold certain viewpoints? Because understanding the reason why the stakeholder group believes certain things can actually inform new suggestions for improvement of these systems and present like a broader explanation of why a person thinks a certain way. And understanding this context can be beneficial in shedding light on why someone is, for example, in favor of a new practice or not in favor of a new practice. So a contextualized understanding can assist in future development of these systems. And throughout the research, I came across several examples of challenges that the operators, for example, faced. The points here are some of the examples, not all of them were included, but an example includes, for example, that there can be a lack of safeguards compared to traditional water systems. Because they're relatively new, there are certain uncertainties in place. But at the same time, when asked about these issues, operators also shared that they had specific thoughts on how they could improve these challenges and what kind of suggestions they had to improve the systems they are working with. So some of my research also presented like certain suggestions of the operators that specifically address the issues they also present themselves. For example, exploring alternatives or increasing practical knowledge higher up, for example, among policymakers. And what this presents is that the exploring of the positioning of operators is not just as simple as investigating barriers and opportunities, since the opinions and views of these operators relate to personal preferences, experiences, as well as their mindset. Sorry, the slides are a bit moving a bit too fast. Yeah, the operators all have different backgrounds, which they base their opinions on, and understanding why they hold certain opinions is thus relevant. And one specific example within his research was that there was a big difference between operators who are in favor of the quick scaling up of these kinds of systems, and some operators are a bit more hesitant. And the reason for this is some operators are working with systems that are implemented on a small scale. Examples are the location in Germany or the location in Kerkrade in the Netherlands, where the operators say, okay, the way the system works now, because it's so small, we're losing potential. For example, there's a lot of rainwater and not all of it can be captured and used to process. And so it should be larger scale because now it's wasted potential. While some other operators say, okay, we are testing this kind of operation on a small scale now, but we still see some issues. And compared to traditional water management, it's still relatively new. So there are still uncertainties and problems that we haven't seen before. So we should be careful with scaling up too fast. So there's a bit of a difference between, for example, those who are also familiar with traditional wastewater management. And based on the different backgrounds, the operators share different opinions. So what my suggestion would be is if you're working within a sustainable development and you're thinking about scaling up, it's important to take in consideration what kind of uncertainties there are within different stakeholder groups that are involved. And something else that was interesting to note is that the stakeholder group of operators specifically, in a broader context, not specifically within this research context, but in general, at times the viewpoints or their criticism can be seen as a barrier. So what that means is that leaders of sustainable innovations think that the resistance of an employee or the unwillingness to go along with scaling up is because it's just a barrier and an issue they have to overcome. But instead, in my research, I shed light on, well, no, this is not necessarily a barrier. This is really important to get insight into there being uncertainties or still issues that need to be tackled within the process. So generally, I want to give out a lesson that it's important to consider operators' suggestions because they can come up with very interesting solutions, and it also makes them more motivated to be involved within sustainable developments. Well, thank you. And then now, let's move on to Is dat great? Dat is heel goed. Yeah. Okay. I think I'm not sharing my screen anymore, right?
No, that's fine. Thank you very much.
So now I will actually ask some questions to Lars, who was one of the operators involved in this study, so we can give more of a practical and personal insight into this topic. Can you first shortly introduce yourself, Lars?
Yeah, hello everyone. I'm working here in NSVA in Sweden. In this anchor project, I've been working with developing a maintenance plan for the backbone systems and the vacuum systems here in the streets.
So then my first question is, can you explain a little bit more about the differences that you experience between the operation of more traditional wastewater management and the water management within this context of the anchor project?
If we look at the difference between vacuum and conventional system here in Helsingborg, some maintenance that have to be done in a vacuum system demands that you turn off the vacuum, and then it affects the end users and it doesn't do that in a conventional system. If we got this disturbance like blockages in the vacuum system, it also affects the users more quickly and more likely several at the same time. So the system needs quicker response time than a conventional system. With today's knowledge, vacuum systems require more maintenance, and end users need to be informed in a greater extent. On the other hand, for example, the properties are not damaged in the case of a blockage. That's a risk when you have got a blockage in a conventional system. The user continue to use the system, and the water can flow back into the basements and damage the properties. There are requirements for more maintenance that will also affect the cost of the systems to compare with a conventional.
Yeah, thank you very much. But regardless of certain issues and challenges that are there that are present within this type of water management, you still are motivated to work with it.
Yeah.
Tell a little bit more about what motivates you.
I think it's exciting to learn new things and to be involved and developing new systems from the beginning. It's a quite big difference what I do in other tasks today. I think it's important that the system is evaluated to see if this is the future, if it's not too complicated or too expensive. And of course, it's important taking care of the planet's resource. This system may help us in the future with water saving and so on. It's also encouraging to work with talented colleagues that on other departments that I usually don't work with.
That's nice to hear. Well, one of the suggestions that a lot of operators actually mentioned for the improvement of these kinds of systems was to increase the amount of automation, so to make sure it's less hands-on and more automated. And what are your thoughts on this?
Yeah, I think so too. I work mostly on the network in the streets, so there I can see it's a big advantage with the motor valves or pressure sensors. The vacuum systems demands a quick response when there is some kind of disturbance. Motor valves can make it easier to control the system without being on site. And pressure sensors on the system can guide you where the disturbance is located. So if you combine these things, like we have done here in Helsingborg, you can, for example, search for leaks automatically at night. We can shut down the motor valves automatically 10 minutes at night and then look at our SCADA system the next morning to see how the pressure sensors have reacted. So I think there is more to come, and then it's an important thing.
Yeah. And what do you think is something that other stakeholders can learn from the practical experience from operators?
I think it's a lot. I think it's important to listen to everyone and everyone's thoughts in this. The operators is the one who have experience from the daily work. It's their work environment that's important to take into account. It's important to build the system with redundancy, monitoring, and automation in mind, to make it easier to maintain. And it can be stressful when this type of system doesn't work. So you have to take this in mind.
Yeah. Thank you so much. That's it for this part of the presentation. So then we'll head on to Hamza next.
Thank you.
Thank you so much, Femke and Lars. Fantastic. And Hamza, go ahead.
Yes, thank you very much. So from the households through the sewer network and down to what comes out in the end. So we're talking about the fertilizer products and what the farmers and the gardeners think of these. And I also work in Helsingborg in Sweden. And the reason why we talk about this is because we have done quite some work on the fertilizers. And that's an integral part of why we are testing this system in Sweden. So first of all, just to remind about the fertilizer products we do have, it's struvite and ammonium sulfate. So struvite is the phosphorus product and ammonium sulfate is the nitrogen product. And these are very concentrated. They have high concentration of these nutrients. They're also clean, especially, of course, if you compare to sewage sludge, which is our normal product. And they are also included in this EU fertilizer regulation already. And so there's the end of waste possibility as well for these. So they're quite mineral fertilizer-like products that we produce here. And that also demands quite a lot of input chemicals, which I say. There's still environmental gain to be had with the systems though. However, ammonium sulfate and struvite, they are like salts and sands. So they cannot be applied directly into agriculture. So then you need a different form, a granule perhaps, or a pellet. And in the trials we did with farmers, we had the pellets you can see here in the picture also. So then you take the mineral compounds and you mix them with the organic sludge, and then you press it into a pellet. And the pellet you have because you can use them in agricultural equipment already. There are pellet spreaders. You can't really throw around sand like struvite. It doesn't work. So we had, together with the local farmers association, 2 of them, and also the National Farmers Association, and then 5 local farmers. We tested these pellet products in the field for 3 years' time. So my opinions, or what I'm about to say here today, is based on the opinions of the farmers and the Farmers Association that were included in this project. Because I work with wastewater, so I don't really know so much about fertilizers. So what did the farmers really think about this product? Well, if I should conclude it, it was like this. The pellet, yeah, they like the pellet because you can spread it with their existing equipment. None of them need to get a special equipment to have the recycling of these nutrients. So they like that we try to fit these products into something already that they work with. However, there were some issues with this specific pellet. So first of all, some dusting. So it produces dust when it moves around in a pellet spreader. And the dust, of course, gets into the air, and then you breathe it or get it into your eyes. So yeah, you could do it. They lived through it throughout these years, but they would like to see a better binding agent in the pellet to produce less dust. They also had an opinion about the application rate you could use, because when the pellet only had 10% nitrogen content, that means in order to produce a full yield of fertilizer on the farmland, the tractor needs to drive very slowly when you apply the pellet, basically at half the speed compared to mineral fertilizer. So that means twice the amount of working hours for the farmer. So that was also a drawback of it. So in the end, I think the main conclusion is really to sum it up. Yeah, this is okay to use. We can live with this. We have pellet products also from other kinds of reuse, from manure and so on. But it's not something we would pay extra for. But basically, it's a proof that already on this scale, and this is a demonstration project on a very small scale, you can get it to work, but in this pellet form. But really leave it up to the professionals, I would say, to make the pellets, because they know it's sort of an art to make pellets that do not dust, I would say. So I think what we are leaning more towards nowadays is more the hobby and the niche markets, because the scale of production here is so incredibly small. We have right now connected approximately 1,000 people, and the amount of black water and then the phosphorus and nitrogen that they produce is very small, the amount of fertilizer product you get out. We're talking about you can, a few hundred kilograms a year or up to a few tons per year. It's nothing compared to the agricultural needs. So then we have also been in contact with hobby fields. So that could be, for example, hydroponic systems or the private parks with flower exhibitions and the local park services. And they have tested these products in all locations. They received samples to test. And they are all interested and they like it. And if I should sum up why they like it and want to buy it, it's very easy to do, because then if we sell them the raw products, the struvite and the ammonium sulfate, it resembles mineral fertilizer. That's basically what they like. So it's a dry product, it's concentrated, it doesn't smell, you can mix it easily, it's storable over time, it's homogeneous in concentration, and you know what to expect when you get it. So it's basically what they like is that it's a mineral fertilizer products, very easy to work with, very similar to what they know from before. One potential buyer of this product has stated that also the local production, that you can create a story around the product you sell, has additional value. But this is one, I should say. Most don't care. They want to buy something and the alternative is fossil mineral fertilizer. But one of them added that this creates a story you can use and a local value. And that's also then for the hobby gardening side. That said, though, we will start selling it in spring, because when we receive the end of waste status. So when in the end we will sell to whoever pays the most, it will be a formal bid. But there exists a market for these products for sure, and there are happy end users also of them. Thank you.
Thank you so much, Hamza. Super interesting. I do not see any questions in the chat. Do I? Oh, there is one question in the questions and answers. From Mario. Very good that you tested the fertilizer over several years. Did the farmers mention any private legal barriers, such as landowners of the fields forbid certain substances from wastewater sector?
No, in Sweden, it's actually common use to spread sewage sludge on agriculture. So almost half of the sewage sludge in Sweden is spread on agricultural land already. And of course, there is legislation to follow, and you need to keep track of where you have applied this. But it's a very well-known thing to do. Also, the bio sludge from the biofertilizer from food waste anaerobic digester is also spread on farmland, and that's also legally a waste that has special procedures to follow. So the farmers are it's a well-known thing to spread what is legally considered a waste on land.
Yes, thank you. I don't see anything in the chat. I have a few questions. Should we continue with everybody else who are here live can also ask questions, but since you mentioned end of waste, Hamza, maybe you can explain a little bit what it is and
end of
what you're
waste.
doing.
Yeah, end of waste is basically that legally these recovered products cease being a waste product in the legal sense and instead become a product and therefore a different set of legislation. And we are interested, it's not necessary to have this status for reuse of these compounds in agriculture, but it helps to create a story and a proof that these things that we produce at the wastewater treatment plant are in fact more clean and therefore can be considered as products instead. And for us, we always compare it to the sewage sludge, which in Sweden we do spread on farmland, but it's a very long ongoing debate whether or not we should be spreading sewage sludge on farmland. So this is sort of the Ferrari alternative to sewage sludge, I would say. And in order to prove it's a Ferrari, we go through the end of waste process.
Excellent. And where are you in that process?
at the pit stop. So we have handed in the end of waste application finally, after, of course, monitoring the quality of these products for several years to make sure it's stable over time. We have handed in the end of waste application this fall, so we expect it to be approved by around New Year's.
Perfect. That's so exciting. We have a question from Brightwater Tools. Fantastic presentation. You mentioned that the pellets are mixed with organic sludge. Where do you get this organic sludge?
Yeah, so it's we have the anaerobic digesters also in the treatment plant, and there we either do anaerobic digestion of the food waste or the black water. And for the pellet trials, we use the sewage, the sludge from the anaerobic digester of food waste. And the reason for doing that was because of scale, because you need to dewater the sludge of the digester. And in order to dewater sludge, you need a minimum volume to work with of some tens of cubic meters. The problem is on this scale, we produce 2 cubic meters of sludge a week. So it's very little to work with. So for practical reasons, we used bio fertilizer sludge from an anaerobic digester of food waste.
Thank you. We have another question for, we have a few questions now from Håkan Jansson, also to Hamza. You tested the fertilizer over several years. Did you compare the yield and quality to chemical fertilizers? Can you show a diagram?
Yes, I'll be happy. The link is actually in the presentation. We compared it to mineral fertilizer. Yeah, that was the reference. But today we're only talking about how the users like the product. But of course, the yield was also good compared to mineral fertilizer. And the report is in the link.
Yes, and we will share the presentations afterwards, I believe. Excellent. And then we have another question. Whenever you design a project, do you make sure it is located near a site where the nutrients can be returned to the soil? If not, what type of transport do you use? Does it reduce the ecological benefit then? That's a wider question, but maybe Hamza is.
Yeah, I can say it. Within the Anchor project, the nutrient recovery is not as important in all the demonstration sites. For example, in the Netherlands, there's a big nutrient surplus because of all the manure and animal handling they have in the Netherlands. So I would say in Sweden, it's the most interesting. And it's been part of the project planning from the beginning. The why we test source separation is basically to have increased clean nutrient recovery, some additional biogas production, and that's about it. We don't really need water reuse in Sweden, for example. We have plenty of fresh water compared to the amount of population.
Yes, and I think there are studies on how far you can transport, for example, urine or black water, and how far you can go away from a site where it's produced. Håkan, who asked the earlier question, has been in the water.
Then, of course, we should be adding that if you produce this struvite and ammonium sulfate, they are very highly concentrated. You can transport them very far.
Yeah,
because you put in a lot of input chemicals to get them that way. But if you want to reuse the wet fraction instead, then you need to think about transport distance.
Exactly. It's much more sensitive to transportation, but there are studies on this. I'll keep an eye in the chat. There is nothing in the chat. So you can continue to pose questions. Oh, here's another one. To Femke. Can you discuss how plumbers and operators were trained in the new systems? Did they become involved in creating manuals and maintenance schedules?
It's not exactly something I know fully everything about, so maybe Lars actually knows a bit about this. But one of the things that I can say is like one of the operators actually gave the suggestion of maybe we should create a manual about this, like collaboratively, in order to educate new operators to be working with these systems in the future. So I think that's something that's actually still in development and being considered right now, because something that within the Anchor project is already a thing, is that the operators do have collaboration amongst one another. where they can share like issues they face and things like this. But because it's still relatively new, I think there is still room for like creating manuals, etc. But maybe Lars knows a little bit more about this because he's practically involved.
Yeah, I think Hamza also talks in this, but of course there is a lot to be. The entrepreneurs need to learn this system too, and I think it's a lot of questions, and the spreading of knowledge is very important in this. But it's also hard when it's in small scale, so that's maybe something that will be easier when this type of system will scale up. But I know Hamza is trying to spread the word with the entrepreneurs here in Sweden.
Maybe Hamza, you want to comment? Yeah.
No, I agree. It's one of the biggest bottleneck is the spreading of the know-how. And I think it's good to have a guide for how to do this with technicians. It's sort of basically how you spread information and get that shared. And there should be more programs on how to do this. I can share a good example is the National Blue Ribbon Commission in the United States that had worked on these topics for direct water reuse systems in buildings. So it's not quite exactly the same as we have, but I think the challenges are very similar. So the National Blue Ribbon Commission in the United States.
And
Thank
maybe
you. Yes. Yeah.
so one
Sorry.
more
Go ahead.
sorry to say about it. It's like, as the question was like, how were the operators trained? I think especially at the locations where the system is still in a small scale. So Sweden is quite large, but on the smaller scale, I think a lot of the operators actually learned from practice because a lot of things weren't known yet. So by doing, they started developing the know-how and the knowledge. Yeah.
Thank you. Yes, we have another question for Femke. You mentioned that some operators prefer not to scale up their systems immediately. Is this mainly a matter of needing more time to refine and optimize the system in order to avoid potential failures? Or is it because certain systems have already shown that they would not work effectively at large scale?
I think it's a little bit of both. I think there are some aspects within certain locations where they actually stopped with aspects of the operation, where like one aspect either it showed that it wasn't functional on a small scale or wouldn't work in the future. But there's like a bit of a difference between sometimes people feel like, okay, I don't think we know enough about this to implement it on a larger scale. But on the other hand, there's also some people who say, I personally feel more comfortable to work with things I know of. So it's not necessarily, well, it's also a little bit of discomfort with something new and needing to have like the proper work context or education to be able to work with something new.
Thank you. I can just throw in a question to Lars from myself then. And so Lars, was it worse than you expected, or was it better than you expected, or was it neutral with the vacuum systems?
I think it was better what we have seen so far, but I think still there is a lot to learn about the systems. We are making a maintenance plan now, but I think it will have to many years from now you have to learn about the system. We can see that the scaling inside the pipes is a problem that we will have to handle with some maintenance. But maybe I was a little bit more afraid about the system than it turned out to be so far. But it's really a lot to learn still.
Yes. Another question for Femke. Did you also work with operators, technicians appointed by building owners to maintain the systems inside the buildings? What do you expect of their perceptions, I think.
Well, in my research, it wasn't really a big part of it, but I have heard some people talk about so I didn't talk to them directly, but I have heard some people refer to like these people who are more in this kind of setting. And most of the time I've heard that sometimes people are, some operators are unwilling to touch these kinds of systems because they don't know how it works. When they work in a different context, they're like, oh, this is something I'm not used to, so leave me out of this kind of. That mindset can at times be present. So I think that they're like informing each other, and I think something that I think it was Lars actually that he shared with me, like that in Sweden they are actually working on informing their colleagues in like the more traditional water management also to help them understand what is this system, what does it mean, and that it actually isn't maybe as different from what they're used to before.
Thank you. There's, I think it will be maybe the last question or second to last. Do you also include experience from other projects like Lübeck, the first system, and Snake, the second project? I think it's for you, Femke, if you looked at Lübeck and Snake. I suppose you didn't, because they're not there.
But I think maybe, maybe someone else did include, because I do know that they were, some colleagues from Snake were present at one of the meetings in Sweden, actually. So I think they are keeping up in a way, but I don't know exactly how.
Yeah, I can say we're in contact with the people in Snake, but I don't really know about the end user's perspective there. And in Lübeck, I should say, I don't know who's in contact with them anymore, but at least not us.
Right. Well, I can say from LTU perspective, if I take another hat, we're trying to apply for funds, Hamza, together with, with some brains behind the Lübeck project. So we're well aware of these experiences. Is there? Oh, okay. Now the absolutely last question. Could you mention that user satisfaction has? You mentioned that user satisfaction has decreased. This is for Henk-Jan. Could you explain why? I didn't quite understand. Is it that the initial enthusiasm tends to fade with daily use? Do these systems require a lot of tiring daily maintenance?
Yeah, I think it's the first. We don't have evidence. We don't really delved into the reasons that it decreased. But it's the early enthusiasm we think that waned off a little bit. So when at the beginning you can be enthusiastic about the new things and how it works, and at some point you get a little bit more used to it, and then it flattens a little bit. Yeah, that's what we think.
I kind of understood it as well, that it wasn't like going more to neutral, like, yeah, it's a toilet.
Yeah, exactly.
Yeah. So not necessarily negative.
No.
Okay, before we end, I need to share a slide to show you about the next where is it? The sharing thing there. The upcoming lunch talk, which is 4th of December. And is it sharing? Yeah. And the focus is we continue on this practical knowledge. Not sure if it's sharing in presentation mode. Yeah. We continue with improvements in practical knowledge of vacuum systems for black water conveyance. So continue on the aspects that we have touched upon today. And it's on December 4th, and it will be Hamza, I think, taking the lead on this lunch talk.
Together with Gregor from Hamburg-Wasser.
So looking forward to seeing you all on December 4th. And bring a friend. Thank you for today.